Okay, so what I'm going to do is I'm going to have a look at the biological reasons why schizophrenia may occur. Okay, we'll have a look at the physiological and psychological reasons in another video. Right, okay, so studies have suggested that schizophrenia runs in families, okay, which is related to the nature against nurture debate. Okay, the nature is related to the genetics, the nurture is related to the environments. It's known that even identical twins have different environments in the womb, so for example one may get more oxygen than the other, okay, and of course identical twins may, whilst they share an environment, have different experiences during their upbringing. The genetic disposition to schizophrenia has been looked at in Gottesman's family study in 1991. Monozygotic twins, in other words identical twins, okay, if your monozygotic twin has it, you have got a 48% chance of getting it. Monozygotic twins share 100% of the genetic structure. Okay, it's worth pointing out in terms of that 48%. Okay, this does suggest that the environment must play a part, because you still have less than 50% chance of getting it even if your identical twin has it. If your fraternal twin, in other words another non-identical twin, dizygotic twin has it, then it drops to 17%, which suggests that genetics does have some kind of basis. If your child has it, you will have 13% chance of having it. If your siblings have it, 9%, and if your parents have it, 6%. And we share 50% of our DNA, and these are first order relatives. If your half sibling has it, 6%. If your grandchild has it, 5%. Nephews and nieces, 4%. Aunts and uncles, 2%. And these share a quarter of the genetic makeup. If we have a look at people who share an eighth, which is our first cousins, that's 2%, and a reminder that the general population share 1% as it is. Okay, so in terms of, not share 1% of DNA, that would be daft. In terms of 1% chance, I should clarify. So 1 in 100 people will have schizophrenia. What I would do is I would plot that in a graph and separate it into the different colours and do that as a bar chart, so that starts out. And that's Gottesman's family studies. There are lots of different studies that have a look at genetics, especially when we look at candidate genes. Okay, so have a look at the genetic makeup of people. Now, we say, and this is the technical term, we say schizophrenia is etiologically heterogeneous. Okay, etiology refers to cause, and hetero refers to different. In other words, there are different causes genetically that lead to schizophrenia. Okay? So, different causes that lead to the cause, differences that lead to the different causes of schizophrenia. Okay? Now, Ripke in 2014 did a genome-wide study looking at the genetics of the global population. And what happened was, he looked at 37,000 schizophrenia patients and compared that with 113,000 control patients. That's people without schizophrenia. So this is a large sample. And what he found when comparing people with schizophrenia with people without, there are 108 separate genetic variations that increase the risk of developing schizophrenia. So 108 separate genetic reasons why somebody might develop schizophrenia. Okay, now there was a large group of information that suggested that any genes that was associated with increased risk, okay, these were the genes that encoded the neurotransmitters. So he discovered a link between, or what he did was he found some basis that suggested there was a link between neurotransmitters and schizophrenia. So let's have a look at neurotransmitters in more detail. So here we've got the presynaptic transmitters on the end and the postsynaptic receptors there, and we've got the synaptic cleft in the middle. What happens is the vesicles spill their contents across the synaptic cleft, okay, and the postsynaptic receptors will pick up on this dopamine as a neurotransmitter. So we're specifically going to look at the neurotransmitter that is dopamine, and this is the Dopamine Hypothesis. Now, it's suggested that there were large amounts of dopamine in the subcortex. This is hypodonaminergia. Okay, so hyper refers to a lot of dopamine in the subcortex. Now, this is because this, for example, would give you an excess of dopamine in Broca's area. Broca's area is related to speech production, and because of this excess of dopamine in Broca's area, this was leading to speech poverty and possibly auditory hallucinations as well. The other aspect, okay, in Goldman-Rakic's study in 2004 was a lack of dopamine in the prefrontal cortex. Okay, this is hypodopaminergia. Okay, hypo being a lack of, for example, hypothermia. Okay, and this was suggested that this lack of dopamine in this area leads to negative symptoms. Okay, we mainly lead towards a simplified model of saying that a high amount of dopamine leads to a bigger disposition for schizophrenia. So we mainly focus on this area. However, you will find out it's a lot more complex than that. The other thing we can look at is brain activity, so how specific areas of the brain behave. Okay, so these are referred to as neural correlates, and this is where structure or an activity of the brain, and what happens is that occurs in conjunction with an experience. So, for example, your brain has an area called the ventral striatum. Okay, and the ventral striatum is related to your reward system in the body. Okay, therefore, it is linked to motivation. And what Juckle et al. In 2006 found that people with schizophrenia had lower levels of activity in the ventral striatum. Therefore, it has links to the negative symptom that is avolition. Okay? In another study, looking at neural correlates, a study was made on the superior temporal gyrus and the anterior cingulate gyrus. And what Allen et al. In 2007 discovered was that there was low activity in those areas for people experiencing auditory hallucinations, and that was comparing them to a control group. Okay? These people were given a task to identify pre-recorded speech and to see if they could identify quickly whether it was them talking or somebody else talking. And what it was found in people with schizophrenia, there was low activity in these two areas. Let's have a look at the evaluations. Okay, so let's have a look at the Finnish study by Pekka-Tienari et al. In 2004. Now, this was a quasi-study in that the independent variable already existed. Okay, so this is natural. So, what Pekka-Tienari looked at was 19,000 mothers with schizophrenia who had had their children adopted between 1960 and 1979. Now, it's really important I point out this is a quasi-study because a common misconception with this is that there was intervention by Tienari, and that is not the case. Okay? He came to look at this after the events had occurred. And what he did was he surveyed the adopting families, and he separated them out into functional and dysfunctional. Okay? Those with schizophrenic mothers who went into functional families were less likely to develop schizophrenia. So even though there's a genetic disposition to developing schizophrenia, it is suggested that there is an environmental impact as well. And therefore it's an interactionist model. Okay? So it's genetic and environmental. Diathesis stress is the trigger. Okay? And what I mean by that is there's a genetic disposition. Okay, but it's not until a trigger is pulled environmentally that the symptoms develop. So, for example, okay, person with schizophrenic mother goes into a functional family, does not develop schizophrenia. The diathesis stress situation is where it goes into a dysfunctional family, and then they develop schizophrenia due to that environmental trigger. Okay? Other evaluations are amphetamines, the drug, increases dopamine. Okay? If people take amphetamines, that can induce schizophrenia symptoms, And those are specifically schizophrenia symptoms being developed in previously non-sufferers. And that was Coronatel's study in 2004 that suggests that anything that increases dopamine can lead to schizophrenia symptoms, thus suggesting that dopamine has an effect. Okay, antipsychotic drugs lower dopamine. Okay, so people who take antipsychotic drugs to combat psychosis or schizophrenia lowers the amount of dopamine. And that's Tauscher et al. Study in 2014, and that suggests that again, dopamine has an impact. Lindstrom in 1999 did a radioactive study where they used radioactive tracers to monitor brain activity. Okay, they found that chemical uptake was higher in people with schizophrenia, and therefore more dopamine was being produced. So a lot of the evidence points to dopamine. Okay, however, Moghaddam and Javid in 2012 had a look at the glutamate hypothesis, and they suggest that the amount of glutamate stimulates the amount of dopamine. So it may be the neurotransmitter of glutamate that stimulates the dopamine, and therefore goes even further looking at glutamate being the cause. Okay, something I need to point out here, all the way through, is correlation is not equal to causation. So, for example, this about the ventral striatum over here, okay, this person may have a lower level of activity, being schizophrenic, okay, which is affecting the ventral striatum. So we can't determine whether it's the ventral striatum affecting the schizophrenia, or whether it's the schizophrenia affecting the ventral striatum. So all the way through, just because there's a correlation doesn't mean that that is the cause. It may be the other way around. And finally, the final evaluative point is these may be down to sperm mutations. Okay, sperm mutations may be caused by radiation, poison, or having a viral infection. And what we find is you get more sperm mutations if the father is older. So, for example, 0.7% of the under 25 parents were having children with schizophrenia. 2% if the parent, when the child was born, was 50, would lead to schizophrenia. Okay, therefore it may be a sperm mutation that leads to schizophrenia. Thank you very much.